So welcome back to another Tech Talk presented by SoilOptix. Today we're joined by Trevor Thornton of Crop Care Consulting, our Western Canadian service provider. And today we're going to be walking through something unique that Crop Care does, which is looking at ratios and other value-added maps. And he's going to walk through some of this with us and what he's bringing to the marketplace in Western Canada. So I will pass it over to Trevor to get us started.
Thanks, Zach. Hello all again for another Tech Talk. I'm Trevor Thornton with Crop Care. We get to talk today about something that you may not have heard before, about different nutrient ratios beyond just some normal ratios that you may have worked with, and then some of the value-added maps that we've added based on either grower request or advisor request of some of the advisors we get the opportunity to work with in Western Canada. So when you're looking at growing a crop, we look at the law of the minimum. I've referred to this in a few of our Tech Talks, and it's important to understand because what's limiting that crop potential. Also, what's the balance of those nutrients? And this is where the ratios also help us dive in a little bit deeper than just the raw nutrient values. So we'll dive right into the K to MG ratio. For folks that have used A&L Labs for a long period of time, this is something that they have supported and got a lot of research on. When you look at any of our ratio maps, just saying here, as anybody's wandering through this and just want to understand it, anything that's in the green categories, those are your optimum levels of where you want to be. Anything outside of that, we've got some challenges. So for the K to MG ratio, we want that somewhere between a 0.25 and a 0.4. This particular field's a little bit low at a 0.2, so we got to work at our potassium to bring that up a little bit. But you can see our ranges from a 0.1 to a 0.5. As we look at variable rate applying potassium and or magnesium on a field like this, we will tighten up these ratios differences, but also point it in the right direction. When we started looking at this and doing correlations to yield maps, we saw some strong correlations to getting the K to MG ratio in the sweet spot versus having it way too low or way too high. Yield drops off pretty fast off of what the potential of a field is. Once you get over 0.4, it drops off a little bit between a 0.25 and a 0.2, but when you get below a 0.2 and lower, it drops off substantially. Now, the challenge that we've had with that is when you're talking with a grower who is growing really good yields with a poor K to MG ratio, and you tell him he's leaving yield on the table, he kind of looks at you like you're squirrely. But the reality is the data is showing us that if you want to work at maximizing your production, there's areas to tweak. And that's what these ratios really help us do, is fine tune and tweak the program. The second map we're going to look at is the calcium to mag ratio. If you read organic agriculture or regenerative agriculture literature, a lot of them talk about the calcium to mag ratio, wanting it somewhere between 5 to 7 or 7 to 10, depending on how it's created. For our maps, we're looking somewhere between 7 and 10, and this particular field is at 5.5. So this map here is telling us, hey, we got to work at calcium to bring it up to the magnesium. The challenge that I have, and I don't get caught up on the calcium to mag ratio, but it is one to look at and consider, is I have not seen a tremendous amount of yield correlations to this being optimum. We have had amazing yields where our cal to mag ratio is either too low, or in a few instances too high. We have had poor yields where this is dialed in just perfect. So I refer to it loosely when we're dealing with a grower and tell them not to get caught up on it. It's certainly not something we do to make nutrient decisions in growing a crop, but it's another layer to help dial it in. Potassium to boron, however, this one is very important, and what we've seen probably second most important to the K to MG ratio. We want this number right around the 200, give or take a little bit. So this particular field's at 330. This field needs some boron. Depending how high it goes, we have fields that are 2,000 to 1 potassium to boron. So meaning they've got gobs of potassium in the background and no boron to get it into that plant. Why is that important? Well, we'll show you on the next slide. But we also have used this ratio and the soil part per million levels in order to build variable rate boron maps. This helps us decide if the field needs boron no matter what crop we're growing or just certain crops. So at a 300, we're pretty close here. We would strongly suggest to this grower, you don't need to be putting boron on every crop you grow, but more of your sensitive crops like maybe canola, you should consider getting some down. and why that boron is important. And you've seen this in our other tech talks, and we keep referring back to it on how a plant grows and how biochemically it starts. We need boron to activate the silica, which binds to the calcium, which gets our nitrogen converted to amino acids, et cetera, et cetera, et cetera, down to our potassium. So if I don't have boron to start this whole process, there's no way I'm getting potassium into that plant. If I've got really high potassium levels and lower boron levels, I'm beat before I started. And when I have growers tell me, oh, I've tried that potassium crap and it doesn't work, and we start diving in, that ratio really helps bring that story home to that grower and say, well, I see why. If you spend, whatever it might be, 2 to 3 liters of acre of a boron product, depending on what it is, that might drastically change the production in that field that grower's looking at. Phosphorus to zinc is another ratio we look at because they're strongly related. Optimum wise, we want it 12 to 18. This particular field is an average of 11. So we're pretty close to the sweet spot. If you're managing your phosphorus and go aggressive on that, make sure you take your zinc with you in a situation like this. Another map in this field, we're looking at our calcium to phosphorus. We're wanting it somewhere between 35 and 70, and that depends on the soil texture background. So the lighter textured fields, we want it on the lower side. The heavier textured fields, we want it on the higher side. This field's at a 35. So what this is telling us is, hey, we've got some not bad phosphorus levels. We need to really focus on the calcium. Another map, when we're looking at our phosphorus and manganese, we want it between a 1.25 and a 2.5, where average is 2. And we're right in the sweet spot. A few areas are higher. This field, they've done a good job managing their phosphorus over time. So we really don't need to go crazy on phosphorus. We look at another map here, phosphorus to copper. We want it between 20 and 30, and they're at 72. Guess what? We need to put a lot of copper on this field and keep the copper nutrition strong because we've got a lot of phosphorus in the background. Another map we look at, the calcium potassium map. We're averaging 9, and we need to be in the 10 to 15, so we're almost perfect. So if all of a sudden we go put on a whole bunch of calcium, we got to make sure we take some potassium with it, especially when you're looking at calcium from a lime application in tons per acre, not just pounds an acre of something else. Manganese to copper, we want that in a 20 to 25, and we're averaging 35. So this particular field, or this particular map, is showing us, this is the second or third map if you actually look at the copper part per million. Hey, we need to focus on copper on this field and make sure that we apply enough in order to get our balances right, but also to feed our crop. When we look at manganese to zinc, we're wanting it somewhere between 8 to 12. This particular field's at 5.6. So this is saying we've got good zinc, but we're a little short on manganese. But remember the previous slide? We've got good manganese when it's compared to copper. So now when we're looking at both of these together, we've got to manage the manganese very, very carefully so we don't skew things out. Again, it comes to that balanced approach. And then the final ratio map is our zinc to copper. So we got lots of zinc, but we need some copper. We want that at a maximum of 2.5, and this particular field's at a 6.5. So when you look at all of these different ratios, what this really does help us bring about to that farm is when we're going through the maps and explaining what we see in them, and we get to those ratios, it helps us dive into what potentially is the most yield limiting factors of that field, and allows us to say, hey, Mr. Grower, these 2 or 3 nutrients are something you should focus on immediate future for your next crop for growing that successfully. Then we can look at and say, hey, Mr. Grower, these are some things that you got to look at more midterm or long term. So that might be a calcium application of some sorts. So when we look at this field, we need to focus on some micronutrients here to really start unlocking the potential. The long-term factor on this field would be looking at our calcium levels to help dial them in better and make sure that we maintain those balances moving forward. But there are scenarios, and I need to say this, that the soil type will not allow us to maximize the optimum balances, and it's just too expensive to do it. So then it's about managing the nutrition to that crop. And we're never going to fix those soils, but it's about managing the delivery system of that crop so we can grow the biggest potential crop that we can. That's going to give us the biggest ROI. So the value of the ratios, it helps us prioritize what nutrients we need to focus on. It's an additional map layer when we're creating some of our RX maps, and it helps us look at the information in a little different way than we're traditionally used to. When we start looking at the value added maps, we create some extra maps to help the growers and their advisors understand better. A lot of the maps have come out of whether it's a farm saying, I don't understand, I'm a dumb farmer, it's a quote unquote, put it in a picture for me, and advisors saying, hey, you got all this information, can we put it together to give us a risk map of some sort? And we do have more maps coming. So the clubroot risk is a big one that we've been asked to put together. What we found is that clubroot risk, 6 and above, you've got a definite challenge with clubroot potentially thriving in your field. 5 and below, not so much. What we hope these maps would do is advisors would be able to, and the growers as well, use them to smart scout your fields and go to the areas of the field with the highest risk. Because if we can identify where those highest risk areas are and you can scout them before the clubroot becomes a big problem that you can't eradicate on a small basis, we can mitigate that risk and then make some management decisions to enhance those areas so we don't increase the spread of the clubroot. When we're looking at clubroot research, this is from Oregon State College from 1958. That's a long time ago. They were specifically looking at calcium, potassium, calcium to potassium, boron, boron to calcium, calcium to boron, and pH and its effects on clubroot and the clubroot disease in different crops. I gave this research to a fellow from Omex, Abdel, who's a brilliant man. And he actually took all the data, ripped it apart, and put it back together. And he said, in their research data, when they got their boron or the potassium to boron ratio to 200 to 1, the clubroot disappeared. When it was lower than that or higher than that, then the clubroot started showing up again. So an interesting fact that the research was there, but just when you look at it a little bit differently, it really shows the value in some of those ratios that we're using to help understand what's going on. So we look at some clubroot ground truthing in Manitoba. We've got a spot where we got a pH of 6 that had a clubroot risk of 4.3 and a pH of 5.4, and we have a clubroot risk of 6.5. This was where clubroot was in that field, and it was in a small area. So our algorithm for figuring out that is pretty tight. Looking at a Munster clubroot field is what the advisor called it in Alberta. When we look at the specs in that field and put it against the algorithm, we're at a 9.5 rating out of 10. So basically, this is one of the ground zero fields. Desperately need to look at some boron, some calcium, and some other things in order to be able to grow canola in these fields again. And this is some work that we were involved with the Canola Council in Alberta on making some recommendations to some plots. So these are soils from this field. And you can see here with no lime, and these plants were maybe 6 to 8 inches tall, so a fairly small plant. You can see how much clubroot's already started with the galls, where they've mixed in the hydrated lime to correct the pH and get the calcium levels right. You can see there's nothing started on that plant. By no means are we suggesting that we're going to eradicate clubroot from the field, but if we can change the environment that the clubroot likes to thrive in and change that, our plants have a chance to get up and going. And maybe we'll have a gall or two on this by the end of harvest, but at least we'll have something to harvest versus this plant will be choked off and mature long before we can get it harvested off that field. And then can we change that clubroot risk? Well, this is a field we're working with, a bit of a research field in Alberta. And as we've changed some of those soil nutrient levels, we've dropped the clubroot risk on an average from a 6.9 down to a 5.9. So we're definitely heading this field in the right direction. Another map we look at, maps we have are sand, silt, and clay, which are very unique to SoilOptix. And I've had growers look at those maps and say, yeah, so what? What does that mean? That doesn't tell me anything. So then we started showing them the texture triangle, but then we said, well, why can't we put that just together and take those numbers and put it in a picture for that grower? So that's what we did. Which includes the texture triangle so they can kind of see where things are at. So this particular field, we got 30% of it is a sandy loam, 69% of it's a medium loam, and just under, well under 1%, we got some clay loam. This actually makes a lot of sense to the growers because when they piece that and see that in the field, well, yeah, that's where it's sandy, that's where it's heavier. Yeah, that really makes sense to me. So that's good. Then we look at fertilizer efficiency, and a guy looks at a chart like this and says, well, that really doesn't mean anything to me. Yeah, so what? I'm losing 53%. But then when you put that in a map, and this particular field, we range from 0 to 53% with an average of 30. Now, all of a sudden, it really makes sense to that grower saying, hey, I'm losing value on a lot of my field. When you look at his pH, his average is 5.4 with a bottom end of 4.9 to a high of 8.3. When we look at that field and look at the dollars and cents, if we leave it untreated and we're spending $100 an acre in fertilizer, that's $30 an acre we're potentially wasting every year. With the potential loss of $20 to $60 an acre of a $500 an acre crop, plug in whatever number you want. That could be $1,000 an acre. That could be $100 an acre. I don't care. Just plug a number in. This is what we've used for this scenario. We're losing between $120 and $330 an acre a year by not taking care of that problem, which is easy to take care of. With that, that's a quick go over of the SoilOptix and what we see for ratios and some of our extra value maps. We are working on more maps. The scab risk map is really close to being released. We just got a little bit of ground truthing to do. I believe we can also work on some forecast maps on weeds. If you watch some of our previous tech talks when we're referring to the soil chemistry, the weed potential, maybe we can be forecasting some more diseases and certainly insects. So I think our imagination and time are our limitations because the data's out there. We just got to piece it together. So with that, thanks for joining us on another tech talk looking at SoilOptix. If you want to reach out and have any questions, or contact information is here. We'd be more than willing to have a chat with you. With that, I'll turn it back to Zach.
Alrighty, well, thank you, Trevor. That was really interesting, and diving into some of the other opportunities you can do with this technology, and ultimately when you have that, have that much information, right? And then, like you said, it just takes a little bit of imagination and time to kind of derive some of these, and that the ratios is something new, I think, probably to a lot of the market. But it just provides another clearer picture of what are some of the limiting factors that are in those fields, and certainly the Clubroot is something I know is as huge for you in Western Canada, right? Mm-hmm. And I'm sure that there's some opportunities to extend that and provide some further insight for guys as they grow that crop, certainly. So no, I really appreciate you taking the time, Trevor. Thank you for everyone for watching episode 5 here of our Tech Talks, presented by SoilOptix in conjunction with Crop Care Consulting and Trevor himself, and be on the lookout for another episode here soon. So thanks again, Trevor.
Thank you.